USB-C was supposed to be one cable that we use for our everyday devices. It was supposed to be the one cable to rule them all, but that's not what happened. Instead, we got a mess of confusion. Your cable might be able to fast charge all your devices, but it may not transfer data at high speed, or it might not be able to connect to your monitor for display. Why so? Because not all USB-C cables are created equal. But first, you have to understand that USB-C is the outer port. Inside your USB-C, there might be USB 2.0, USB 3.0, Thunderbolt, or other technologies. So let's talk about them. Let's talk about speed, because this is where the naming conventions go from confusing to actually malicious. USB 4.0 was supposed to clear out confusion, but it still created much more confusion. In theory, it has 40 gigabit transfer speeds, fast charging like 240 watts, support 2 4K monitor display, external GPU, cable docking, etc. But that was not the case with USB 4.0. Most of the features I explained above are optional. That means that it's up to manufacturers whether they want to implement certain features or not. For example, minimum PC data rates for USB 4.0 is 20 gigabits, and 40 gigabits is the maximum. And for charging, 7.5 watts is minimum. And all other things like support for 2 4K display, external GPU support, etc. are all optional, so you could see why it would cause confusion. Okay, so data is a mess. What about power? Surely charging is simple. No. Okay, so first of all, in smartphones, almost every manufacturer have their own proprietary charging. But there are some standards like power delivery and quick charge that are present in some phones, but power delivery is more mainstream adopted. It has different versions, but it is rather easy as it is written on cable packaging if it supports PD charging or not, and wattage is written on it, for example 60 watts, 100 watts, 140 watts, 180 watts, 240 watts, etc. And then there is the Thunderbolt. Thunderbolt 3 and 4 use the USB-C connector, but they are strictly regulated by Intel. Consider Thunderbolt as a version that has higher base standards than USB. If you see this lightning bolt, then that means it is Thunderbolt. USB 4.0 is based on Thunderbolt 3, which is developed by Intel. Let's take a look at Thunderbolt and USB 4.0. As you can see in this chart, unlike USB 4.0 that has minimum speed of 20 gigabits, while Thunderbolt 3 and 4 have higher minimum speed requirement of 40 gigabits, and Thunderbolt 3 have to have at least one 4K monitor support, and Thunderbolt 4 has 2 4K as minimum. Instead of having features as optional, Thunderbolt implements higher minimum specs so that you can be assured that what you are buying comes with at least these features. But it comes with a catch, as Thunderbolt is not present on most of AMD PCs or laptops, while USB 4.0 can be implemented on almost every device. So a USB 4 cable might be just as good as a Thunderbolt 4 cable, but it costs half as much. Or it might be missing features because USB 4 makes some of those requirements optional. It's a gamble. This is the one that makes people return products. You buy a nice USB-C monitor, you plug in the cable that came with your phone, nothing happens. That's because sending video requires a feature called DP alt mode. Many charging cables only have the wires for electricity and slow data, USB 2.0. They physically do not have the wires inside to carry a video signal. So you have to make sure USB-C cable is advertised as USB DP alt mode in order to get a display out. This is the logo for DP alt mode. If you see this, then it means the device supports it. In order to display via USB-C, you have to make sure all the devices are compatible. For example, device from which you were sending signal, that is PC, laptop, mobile, are compatible. USB-C cable that you were using is certified for USB-C DP alt mode, and lastly, your monitors support USB-C display or not. If even one of these things is not compatible, then there will be no display. Docking. Now let's talk about docking stations and external GPU. What are those? Have you ever used a USB dongle that converts one port into many? Docking stations are similar to that, but they have external power so they can charge your laptop while providing multiple extra ports. On the external GPU are enclosures that provide option to connect a GPU to your laptop. While they don't provide full bandwidth, as they are limited to 4 PCIe lanes, they are an option if you want to game on your laptop, but you might not get full performance out of your GPU due to various limitations. Okay, I've scared you enough. The system is broken, but you still need to buy cables. Here is how you survive the USB-C apocalypse. 1. Ignore the version numbers. Look at the transfer speed printed on packaging. For example, 5 gigabits is printed on cable. Only buy what you need. If you need for charging, then buy only by looking at how much wattage it can charge, as you'll be needing that only. On the other hand, if you want for file transfer only, then buy only USB that have higher data transfer speed. 2. Look for the logos. The USIF has finally released certified logos that tell you the wattage, like 60 watts or 240 watts, and the speed, like 40 gigabits, right on the packaging. If a cable has no logo, assume it's the worst version. 3. If you want one cable to do it all, then buy Thunderbolt or USB 4.0. Thunderbolt being the safer choice, but if you can look for the right USB 4.0 cable, you might be able to save money. If you have the money and you just want it to work, video, data, charging, everything, buy a Thunderbolt 3 or Thunderbolt 4 cable, depending on use case. USB-C is amazing when it works. It really is the future. We just have to survive this awkward teenage phase where every cable is lying to us. If you learned something, hit that like button. If you're still using micro USB, I can't help you. Thanks for watching.